Hi everyone, I want to welcome you to this webinar where we're going to review best practices for protecting your data using EBS Snapshots. My name is Jeff Bartley and I'm a storage specialist on the Solutions Architect team here at AWS. On the agenda for today, we're going to start off by doing a quick overview of EBS. We'll then review some of the basics around EBS Snapshots. From there, we'll cover various topics around working with snapshots. We'll take a look at the new Data Lifecycle Manager service for creating and retaining backups of EBS volumes. We'll also look at how to use EC2 Service Manager to invoke the VSS service on Windows instances. After that, we'll look at new features around tagging and resource level permissions, as well as encryption, copying, and sharing of snapshots. Finally, we'll review some best practices for monitoring snapshot costs. So let's start with an overview of the Elastic Block Service. EBS is block storage as a service. With an API call, you configure block storage volumes and attach those volumes to EC2 instances. Volumes can be up to 16 terabytes in size, and EBS provides several volume types to meet the performance needs of your applications. EBS is a service that is accessed over the network, providing our customers with a number of benefits that we'll discuss in the next few slides. When an EBS volume is attached to an instance, it will look like a disk, but it's important to remember that an EBS volume is not a single physical disk drive. Instead, EBS is a distributed system, and each EBS volume is made up of multiple physical devices. By distributing a volume across many devices, EBS provides added performance and durability that you can't get from a single disk device. EBS currently provides 4 different volume types. 2 of these volume types, GP2 and IO1, are SSD-based, delivering both high random I/O operations as well as throughput. The GP2 volume type is designed to handle most workloads well and should be the starting point when building EBS architectures. For customers that need mission-critical performance and consistent low latency, we provide IO1 volumes. These volumes allow you to provision exactly the I/O operations that you need for your applications, up to 32,000 IOPS per volume. For workloads that are more throughput-based, we provide the ST1 and SC1 volume types. A single ST1 volume provides up to 500 megabytes per second of throughput and is designed for active workloads. The SC1 volume type provides up to 250 megabytes per second and is designed for less intensive workloads. An important characteristic of EBS volumes is that they can live independent of EC2 instances. This gives you the ability to select and change storage and compute based upon your workload, selecting just the right resources to meet your application needs. This means that you can detach a volume from one instance and reattach it to a different instance within the same availability zone. The data on the EBS volume is completely preserved and made instantly available to the new instance. A single EC2 instance can have multiple volumes attached to it. However, an EBS volume can only be attached to one instance at any point in time. As a best practice, it's recommended to separate boot volumes from data volumes. You'll want to keep the boot volumes as small as possible and store your data on separate volumes. This gives you the flexibility to adapt the storage architecture to your needs. EBS is designed for 5 nines of availability and a 0.1 to 0.2% annual failure rate. A good way to think of the AFR is if you have 1,000 EBS volumes running for 1 year, you should expect that 1 to 2 of those volumes will have a failure. For customers that want to maximize their durability by backing up their volumes on a regular basis, we provide EBS Snapshots. So knowing a bit about EBS, let's talk about snapshots. So what is an EBS snapshot? Well, it's a point-in-time backup of an EBS volume, saving only the blocks that have changed on the volume since the previous snapshot. If it's the first snapshot on the volume, then it contains only the blocks that have been written since the volume was created. All EBS snapshots are stored in S3, taking advantage of its scalability and 11 nines of durability. However, it's important to remember that EBS snapshots are not stored as user-accessible objects. Rather, they are accessed using EBS API calls. EBS snapshots are crash consistent, and we'll talk about what that means in a few slides. Finally, each snapshot contains all of the information needed to restore a volume to the exact point in time when the snapshot was taken. Our customers use EBS snapshots for a number of purposes. Of course, at the top of the list, they use snapshots to make backups of their EBS volumes. Snapshots also allow our customers to meet their RPO requirements. RPO basically dictates how often data needs to be backed up. RPO requirements can vary from customer to customer and usually depend upon the type of data that's being stored on the volumes. Our customers also use snapshots to make copies of their volumes within or across availability zones when they need added levels of redundancy or for applications that can benefit from read scaling. For disaster recovery, customers can use snapshots to copy volume data across AWS regions. We also have customers that want to make sure they are testing against production data. So they will take snapshots of production volumes and then share those snapshots with their test and dev accounts. And finally, EBS snapshots store the data behind Amazon machine images. As I mentioned earlier, EBS snapshots are crash consistent. What this means is that a snapshot will always contain all of the blocks that existed on the disk at the time the snapshot was created. Any data that's not on the disk, and this might include data that's being held by the kernel in memory or data that's in application memory that hasn't been flushed to disk yet, won't be included in the snapshot. And a good way to think of this is that the state of a crash consistent snapshot is similar to what's on disk if you were to pull the power cord from a computer. Application consistent snapshots are a step beyond crash consistent snapshots, and they provide an extra guarantee of the contents on disk at the time the snapshot is taken. Achieving this added guarantee requires additional steps at the application or operating system level. To take an application consistent snapshot, the application must first halt all writes, flushing any outstanding application data to disk before issuing the snapshot create command. As soon as the snapshot create command returns successfully, the application can be unlocked and I/O can resume normally. Now, application consistent snapshots can be taken automatically on Windows instances running applications that support VSS, and we'll talk about this in a few slides. They can also be taken on Linux instances, but this requires additional custom scripting within the instance. So let's talk for a little bit about how snapshots work. As I mentioned earlier, snapshots only back up changed blocks. If a snapshot is made on a brand new volume, then the snapshot will be empty. No blocks will be stored, and there will be no cost for the snapshot. The AWS Management Console will show the snapshot size to be the size of the volume, but that only reflects the total capacity of the volume the snapshot was taken from. It doesn't reflect the number of blocks actually stored in the snapshot. So having started with a brand new EBS volume, let's write 3 blocks worth of data. And then let's create a snapshot. The snapshot will contain the 3 blocks that were written to the volume, and the cost of the snapshot will only be the capacity consumed by those 3 blocks. Now let's modify blocks 1 and 2. And let's write 3 new blocks, blocks 4, 5, and 6. If we take a new snapshot, then we'll only capture blocks that have been modified since the previous snapshot. Blocks 1 and 2 were modified, so a copy of those blocks will be in the second snapshot. But block 3 wasn't modified, so the second snapshot will only contain a reference to the block. It won't contain the block data itself. And then, of course, blocks 4, 5, and 6 will also be stored in the snapshot. So what's going to happen if we delete the first snapshot? That snapshot contained 3 blocks, 1 and 2, before they were modified, as well as block 3. That third block is referenced by the second snapshot, so before we delete the first snapshot, we need to move the third block over. The second snapshot now has all of the data needed to restore a volume to the point in time when it was taken. It's also important to point out that by deleting the first snapshots, the data in the original blocks for blocks 1 and 2 is now gone and cannot be retrieved. Now, let's write 3 more blocks to the volume, and then take a third snapshot. In this case, blocks 1 through 6 haven't changed since the second snapshot, so we'll just store a reference to those blocks. However, blocks 7, 8, and 9 are newly modified, so we need a copy of those blocks in the third snapshot. So the cost of the third snapshot will only be the cost of those 3 blocks, blocks 7, 8, and 9. When we talk about the incremental nature of EBS snapshots, this is what we mean. Only modified blocks are stored, and you only pay to store the blocks that have been changed. Now let's talk about managing and working with snapshots. There are generally 3 recommended methods for creating snapshots. First, of course, you can take snapshots manually through the console or using the CLI or API. You can also use the newly released Data Lifecycle Manager, which will automatically take snapshots according to a predefined schedule, as well as retain a specific number of snapshots over time. For Windows instances, you can use the EC2 Service Manager and the run command to take snapshots through VSS, which is a Windows native process that allows volume backups to be performed in an application-consistent manner. In the next few slides, we'll talk in more depth about each of these methods. If you need to manually create a snapshot on a volume, you can use the CLI command create snapshot, or you can trigger a snapshot through the AWS Management Console. This method works great for quick, one-time snapshots or for light scripting. However, we have many customers that need to back up a large number of volumes or manage a large number of snapshots. For these customers, we've introduced the Amazon Data Lifecycle Manager, a new service that we just launched a few weeks ago. It provides a simple, automated way to back up EBS volumes and to retain those backups for as long as needed. Data Lifecycle Manager, or DLM for short, uses policies to define backup schedules. You specify when you want a snapshot to be taken and how often, and the DLM service will take care of creating the snapshots for you. When you define the policies, you also specify how many snapshots you want to retain. DLM will automatically take care of expiring old snapshots. This is a great feature for our customers that need to hold on to snapshots for a certain period of time, or who need to retain a certain number of snapshots for compliance and auditing reasons. This also helps our customers keep snapshot costs under control by removing snapshots that are no longer needed. When you define a DLM policy, you specify volume tags to identify which EBS volumes should be backed up. This allows a single policy to be applied to multiple volumes. And you can also use IAM to fully control access to DLM policies. And finally, there's no cost to use the DLM service. You only pay for the cost of the snapshots themselves. Now let's take a look at 2 example policies. Looking at the first example, let's say that you have a requirement to back up all of your root volumes once per day, and that backups should be retained for 7 days. You would define a data lifecycle policy by specifying the EBS volume tag to use. In this example, that would be a key of vol type with a value of root. We want to take 1 snapshot per day, so we'll tell DLM to take a snapshot every 24 hours at some time, say 0700 UTC, and then we'll retain the most recent 7 snapshots. As another example, your company may require that all finance and accounting data is backed up twice each day, and you need to retain those backups for 10 days. In this case, you would specify volume tags that identify the finance and accounting data and you would create a single policy that applies to both types of volumes. You would tell DLM to take a snapshot every 12 hours, with the first snapshot taken at, let's say, 0900 UTC. And then, to meet our goal of retaining 10 days worth of backups, we would want to tell DLM to hold on to the most recent 20 backups, since we are taking 2 backups each day. Now currently, DLM allows you to take snapshots either every 12 hours or every 24 hours. If you need to take snapshots more often than this, you can use multiple tags on the same volume. So for example, let's say we want to create a snapshot every 8 hours and retain 7 days worth of snapshots. We would go ahead and add 3 tags to our volume to be backed up. The key value pairs can be anything that makes sense for your organization. We would then define 3 separate policies, one for each tag, running once per day for each policy, and we would stagger the start time so that it was offset by 8 hours from the other policies. In this case, we'll have 3 snapshots taken each day on the volume, with the snapshots occurring at roughly 8-hour intervals. Here are a few things to keep in mind when using the Data Lifecycle Manager for EBS Snapshots. First, when specifying multiple tags in a policy, keep in mind that the policy applies to any of the tags specified. A snapshot will be generated for each volume with a matching tag. Second, a volume tag can only be used in one DLM policy. If you try to create a policy with a volume tag that has been already assigned to an existing policy, then the create attempt will fail. Also, keep in mind that snapshots are guaranteed to be taken within 1 hour of the specified start time. The snapshot may not always be taken exactly at the time specified in the policy. As I mentioned earlier, DLM backup periods are currently every 12 or every 24 hours. And finally, to enhance manageability of snapshots, DLM will automatically apply AWS tags on each snapshot that it generates. In addition, you can also specify custom tags to be applied to each snapshot as well. As I mentioned earlier, if you have Windows instances running applications that integrate with VSS, then you can take application consistent snapshots across all of the volumes attached to your instance. To do this, you'll need to either create an IAM policy or update an existing policy with the appropriate actions and ensure it's attached to your Windows instance. From there, you can take VSS-enabled snapshots on Windows by calling the AWS Windows Create VSS Snapshot Run command. You can do this from the AWS Management Console, the CLI, a custom PowerShell script, or even a Lambda function. When you're ready to run the command, you specify the instance to run on and any tags to be applied to the snapshot. You can also choose to exclude the boot volume from the snapshot process. When the run command is executed, the VSS agent running on the Windows instance will stop and will flush all I/O from the application prior to creating the snapshot to ensure a fully consistent snapshot is created. The Service Manager packages that contain the VSS agent are available with recent Windows Server AMIs. And you can also install these packages using the Configure AWS Package Run command. Now, we've already talked about tags quite a bit and how useful they can be in managing your snapshots. For a while now, we've supported tagging EBS volumes during creation, and recently we also added the ability to tag snapshots on creation as well. Tagging snapshots during creation is an atomic operation. The snapshot must be created and the tags must be applied for the create operation to be successful. If either one of these operations fails, then the snapshot creation fails. This helps ensure that snapshots are properly tracked from the moment that they are created. It also means that any IAM policies that apply to snapshot tags are enforced immediately. And now, with the ability to apply tags at snapshot creation, our customers no longer need to roll their own scripts to tag snapshots after they've been created. And this is a quick screenshot of the updated AWS Management Console for creating snapshots. You can see that we've added a new tag section, allowing you to add up to 50 tags to your snapshot when it's created. The same functionality is also available in the CLI and the API. In conjunction with Tag on Create, we also added IAM resource level permissions on EBS Snapshot APIs. This feature allows you to use tags to control access to snapshots. You can do things like require that a certain set of tags are applied when a snapshot is created, or you can restrict which users can take snapshots on which volumes. You can also control who can delete snapshots. And these are just a few of the possible use cases for this feature. For example, here's an IAM policy that will restrict access to the delete snapshot API in the US East 1 region if the snapshot is not tagged with the user's name. This is just one possible method for preventing users from deleting snapshots that don't belong to them. When you're creating snapshots, here are a few things to keep in mind. First, because snapshots are stored in S3, they always live in the region in which they were created. If you want to restore a snapshot to a volume in a different region, you first need to copy the snapshot to that region. Second, creating one snapshot at a time does not impact the EBS volume. However, you should avoid taking multiple snapshots simultaneously on the same volume, as this could degrade volume performance. Where possible, use the new Data Lifecycle Manager service to automate taking and retaining snapshots. And finally, use tags liberally to categorize and organize your snapshots. EBS fully supports encryption on volumes and snapshots. When enabling encryption, here are a few things to remember. First, when you take a snapshot of an encrypted volume, that snapshot is automatically encrypted. And when you restore a volume from an encrypted snapshot, the restored volume is encrypted also. EBS uses KMS keys to perform encryption. EBS will create a default managed key, or CMK, in each region where EBS is used. This key can be used for encrypting volumes and snapshots, but it's fully managed by AWS and can't be modified. If you need more control over your encryption keys, then a custom CMK can also be created, and we'll talk about this more in the next slide. When you copy a snapshot that is not encrypted, you can encrypt it during the copy process. Likewise, when you copy a snapshot that is encrypted, you can change the encryption key during the copy process. Note that changing the encryption status when copying a snapshot will result in a full copy of the snapshot, as opposed to an incremental copy. When encrypting EBS volumes and snapshots, it's considered best practice to use a custom CMK. You can create a custom key in the IAM Management Console or using IAM APIs. A custom key provides a number of benefits. It gives you the ability to define key rotation policies on the keys you create. It allows you to fully audit how the key is used for encryption and decryption. You can control who can use the key, allowing you to limit decryption of sensitive data. And it also allows you to control who can administer the key. Now, given the recommendation of using custom CMKs as a best practice, we recently added the ability to encrypt EBS volumes with custom keys at launch time. This is available through the EC2 Management Console and the Run Instances command. Now, in addition to encrypting EBS snapshots, EBS also gives you the ability to copy snapshots, both within the same region and across regions. Here are a few things to remember when copying snapshots. First, snapshots must be in the complete state before they can be copied. If you have a large volume with lots of changes since the previous snapshot, it may take several hours or more to complete taking the snapshot. Copying snapshots within a region has no cost so long as the encryption state is not changed during the copy process. If you change the encryption key during the copy, then a full copy is made and you will be charged for the new snapshot. When copying snapshots across regions, the first copy will always be a full copy. That means all of the blocks needed to restore the volume to the snapshot state will be copied. However, additional cross-region copies of the same snapshot will be incremental, so long as the encryption state doesn't change during the copy process. Finally, keep in mind that tags will not be copied across snapshots. you'll need to either set new tags or reapply tags on the new snapshot. In addition to copying snapshots, you can also share snapshots with other accounts. When you share a snapshot with other accounts, you are giving those accounts permission to both make a copy of the snapshot and, if the snapshot is encrypted, create a volume directly from the snapshot. Our customers use sharing for a variety of reasons, including to make AMIs available to others, to use production snapshots in test and dev accounts like we mentioned earlier, and to copy snapshots to restricted accounts for long-term archiving. It's important to remember that the encryption state of a snapshot influences how it can be shared. If a snapshot is not encrypted, then it can either be shared publicly, which means that anyone has access to it, or it can be shared privately, which means that only a limited set of accounts have access to the snapshot. If the snapshot was encrypted with a custom CMK, then it can be only shared privately. But in addition to sharing the snapshot, the key must also be shared. Without access to the key, the snapshot can't be copied or decrypted. If the snapshot was encrypted with the default EBS managed CMK, then it can't be shared at all, since the default key itself can't be shared with other accounts. So before we wrap things up, let's talk a bit about monitoring snapshot costs. We've talked quite a bit already about the value of tagging and how tags can be used with Data Lifecycle Manager and resource level permissions. Tags also allow you to gain greater visibility into snapshot costs. Tags can be activated as cost allocation tags from the billing console. When you do this, it tells AWS that the cost data for these tags should be made available throughout the billing pipeline. This then allows you to do detailed billing reports broken down by tags, so you can better understand your snapshot costs. To activate tags for cost allocation, go to the billing console under the cost allocation tags section. It will take about 24 hours for the tags to be activated. Once they're activated, you'll start seeing the tags in detailed billing reports, and you'll also be able to do visual breakdowns in Cost Explorer. So to wrap things up, we started out today with a quick EBS overview, and then introduced snapshots and how they're incremental in nature, saving only the data that is changed between snapshots. We introduced Data Lifecycle Manager for EBS Snapshots and talked about how it can help you automate both creating snapshots and retaining snapshots for archival or compliance purposes. We talked about creating application consistent snapshots on Windows instances using the EC2 Service Manager and the run command, allowing you to take advantage of VSS capabilities on Windows. We also talked about the new tag on create capabilities for snapshots, as well as resource level permissions to enable greater control over creating, managing, and deleting snapshots. We also talked about best practices for encrypting snapshots, particularly using CMKs for additional security and control. And then finally, we showed how tags can be used in a variety of ways, particularly for enabling in-depth cost monitoring of snapshots. And that's it. I want to thank you for your time today and wish you a great day. Thank you.